Hello and welcome to my new video. This time it will be about satellite orbits. Why about satellite orbits? Well, I think satellites, that's one of those topics where we have seen tremendous progress in the last, let's say, 30 years without much notice of the public. And I want to change this, and I think that satellites will become in future very important. And therefore, I want to make a whole series about satellites. It's not only about orbits, but also about how they are actually working, how they are measuring things, for example, and which kind of profit we are gaining from satellites and how they are changing our worldview. The view, how we see the world, is actually strongly changed by actions of satellites. Okay, but for today, we start with a very basic topic with the orbits of satellites. Let's start by looking at the physical laws determining satellite orbits. And we are looking here at an ideal circular orbit. And in such a case, the gravity attracting the satellite towards Earth has to have the same value as the centrifugal force which is driving the satellite away from Earth. Both forces depend on the distance of the satellite to the center of Earth, and both forces become larger when distance becomes smaller. So when the satellites are close to Earth, gravity and centrifugal force will be large, and when the satellite is further away from Earth, it will be smaller. And centrifugal force, in addition, depends also on the velocity. So the faster the satellite is moving, the stronger is the centrifugal force. Now, if you set up an equation where the centrifugal force and the gravity have to have the same value, otherwise the circular orbit won't be stable, then you can solve this equation for velocity, and you will end up with relations which I have indicated here. So the velocity is proportional, indirect proportional to the distance to Earth center. That means the closer the satellite is to Earth, the faster the satellite will move. Velocity, however, is not the main point here. More important than velocity is angular velocity. This is marked by omega here. Velocity is marked by v. And angular velocity means how fast a given satellite will cover a given angle when observed from Earth. So, for example, how fast a given satellite will make one orbital turn. And since an orbital turn is much longer when the satellite is farther away from Earth, this is depending much more on the distance to Earth than velocity alone. So what are the consequences of this dependence of velocity and angular velocity on the distance to Earth? The main consequence is that this distance to Earth is the most important parameter if you look at satellite orbits. This is really determining how the satellite is flying and what the satellite can observe. You can distinguish three different kinds of satellite orbits depending on the distance to Earth. I have labeled them here with different colors. The lowest one, smallest distance to Earth, are the so-called low Earth orbits. And these orbits, satellites are flying very fast. They're moving very fast. They are circling Earth at least 11.25 times a day. These satellites, these low Earth orbit satellites, are moving in a height of about 200 to 2000 kilometers above Earth's surface. And the other extreme here are the geostationary orbits, which I have labeled in red color. These are located at 35,786 kilometers above Earth's surface. And here, satellites are moving much slower. They are circling Earth in exactly one day. Since Earth itself is circling at one revolution per day, this means the satellite won't change the position above a given point on Earth. So they will stay all the time above the same position on Earth. The orbits between these low Earth orbits, which end at 2000 kilometers height, And the geostationary orbits, which is about 35,786 kilometers above Earth surface, are called medium Earth orbits. These are the ones which I have labeled in blue color. And these medium Earth orbits will circle Earth slower than the low Earth orbits, so they will not be able to circle Earth in, let's say, 11 times a day, but they will be faster than the geostationary orbits, so they will circle Earth more than once a day. What are the consequences of these different orbits for the area which the satellite can cover on Earth, or which it can observe, or where it can provide services? That's the main question I want to address in this video. And let's start looking at this question by looking at low Earth orbit satellites. And here we've got an example where the orbit is tilted somewhat towards the equatorial plane, and you see then that, if you look at one turn, the satellite will cover, one strip on Earth, which is a bit tilted towards the equatorial plane as well. The satellite will do one turn in a few hours, and in this time, Earth will have moved by a certain distance. So when the satellite does his second turn, he will have a look at a different area on Earth, and it means in the long term, the satellite will be able to cover this strip, which I've marked here in dark color, surrounding the equator to a certain distance, depending on the angle with which this orbit is tilted towards the equatorial plane. From this, it becomes clear that the larger this angle is, where this orbit is tilted towards the equatorial plane, the larger is the area the satellite can observe in whole. And the extreme case then are so-called polar orbits. This is such a polar orbit, so the satellite is flying above the southern and the northern pole, and each time he finishes an orbit, Earth will have moved by a certain amount, and this means the satellite is able to cover the whole surface of Earth. He is able to monitor the whole surface, and he's able to provide services to the whole area. The advantage of such low Earth orbits is that satellites are very close to Earth's surface, so they can monitor Earth very closely, and they can look at many different details and monitor these details. One disadvantage of such an orbit is that there may be remnants of Earth's atmosphere, which may be slowing down the satellites, and the satellites have to be able to accelerate and to maintain the orbits. Another disadvantage would be that satellites are not able to continuously monitor a given area, so will they will cover whole surface of Earth, but they will not be able to continuously monitoring a given area. Such a continuous monitoring, on the other hand, is possible by geostationary satellites. They are located always above a given region, and they are able to really continuously monitor this area every second if you want. And that's the big advantage. The disadvantage, of course, is the large distance, though they will not be able to cover as many details as the low Earth. Thanks for having listened up to here. Next video will be about how satellites are able to measure things. So I will speak about some techniques satellites are using to measure things here on Earth. And I think it will become clear how strongly satellites are revolutionizing our view on the world and the things which we know about the world, and how important they really are, both scientifically but also for the general public. Up to then, see you.